Hello everyone. So I'm back with another video about the dynamic destruction system. So in this video, I'm going to make some improvements and also fix some bugs that was still present in the code. So if you downloaded the code from GitHub and try to run it, what you've seen is, just give me a minute. So if I play it, what you'd see is that if I click on the disk on the statue's right arm, this got destroyed. However, there was another piece that fell from here, which is odd and obviously shouldn't be happening. And why is that? So that is actually because if I go to the code now, so in our destroyed piece controller, obviously we were storing the current position, rotation, and local scale values into the starting position, orientation, and scale variables. And I also told you that we could actually increase the size, increase the scale of the destroyed pieces, which basically means the pieces of the fractured mesh. And if we did that, there would be a higher probability that each of the pieces would collide with its neighbors. And I didn't do it the last time because I thought I would need it. However, in our case, actually, we are missing a few pieces if we do not scale our fractured pieces. So what's basically happening is this piece, which is cell number 81, is actually not colliding with its neighbor, which is this one. And because that's not happening, there is no path from the root to this piece. And in the beginning, when we click on the disk here, we are running the breadth first search algorithm from the root, which is somewhere around here. And it is not able to find this piece either. Obviously, it's not finding this, but also not finding this piece either. And so this is getting detached, and we don't want that to happen. And the fix to it is pretty simple. What we can just do is increase the local scale of each of the pieces. So let's do transform local, not Euler angles. It should be local scale. And increase it by 1.02f. I'm choosing this value because I tested it earlier and that value worked. You don't want it to be too high. If that is the case, then it will collide with other pieces that it shouldn't be colliding with. So it's kind of like a fine balance. So anyways, so with 1.02f set as a local scale, let's run our program again after it compiles. Okay, so if I press play, everything should be fixed now. So if you missed it, I'll run it again. I'll pause it and then run it. Okay, so as you can see, you can kind of make out the pieces much more now, and that's because we increased the scale. And if I unpause it, after 10 physics steps, it goes back to normal. However, if I now click on the disk here, as you can see, this piece didn't get detached. And that's basically what we wanted. So everything is working fine right now. So that was one of the issues, and that is fixed now. The other issue is that since we are doing the breadth first search starting from the root node, which we assign here in the destructible object controller here, if we actually click on the root node, the whole thing will collapse. Obviously, we don't want that to happen. And this is happening because there's just one root node. So if we detach one of the root nodes, everything else that is attached to it also recursively gets detached. And so the whole thing crumbles down. So one fix for this would be, and what I will be trying in this video, is having multiple roots. So basically what we can do is having all of the pieces, or at least quite a few pieces from the base here as the root node, And in that way, even if one of these gets detached, there will still be paths from the other root node, from the other root nodes, and that way the whole thing is not going to collapse, hopefully. So let's work on that. So right now we just have this one root node. If I go back to the code, instead of this one, we can have a whole list of root nodes, or we don't really need a list, we can just make an array. So let's do an array of size. Actually, do we need the size? Yes, let's do new game object. And let's try out with, let's say, 4 root nodes. Okay. And also let's call it roots because we have multiple. And obviously it's going to freak out now. But that doesn't matter. We also have to make this an array of size 4. So going back here, we cannot just take the first one. What you have to do is iterate through the roots and get the destroyed piece controller from each of those. So let's do a for each loop. We can do root in roots. And so actually, no, we cannot do that. It has to be a for loop because we need an index. So let's do integer I equals 0, I is less than 4, and I plus plus. So what we're going to do is also, let's name it pieces instead. Pieces. We're going to put the ith destroyed piece controller from the roots array into the root dest pieces array. So we should have everything we need here. And finally, instead of running this only once, what we're going to do is run it 4 times. So again, I is equals 0, I equals 0, I is less than 4, plus plus. Let's run it 4 times, and every time we're going to use a different root dest piece. And that should, in theory, solve it. We still need to go back and assign the variables in the inspector. So we had, I think one of those were 70, I think. Let's see what 70 is. So yeah, 70 was one of those. We can actually select a few more from here. Maybe this one. Okay, so let's do 14. Let's do, what is it? Is it 70? Yeah, it is 70. So also do 70. Let's do one from this side. This one is 53. And we will also do 73. So 53 and 73. So 53 and 73. Okay, so let's see what happens when we run it. Cool, so it works as before. And if we destroy this one, you can see nothing happened. And it's all fine. If we destroy this one, still fine. Destroying this one is still fine. We cannot actually reach the back one, but there we got it. And finally, it all crumbled down. So that was a quick fix for the problem we had. Now, there's still some issues, as you can see. Specifically, if I run it again, if there's just one path from like one of the pieces to the rest of the mesh, it's still going to crumble down, right? So let's say this was not there, this is not there, and as you can see, I mean, it still looks kind of unnatural. Fixing that would take actually quite a lot of work. So I'm not going to try solve that here. However, I still think this is quite a significant improvement to the system. And that was a quick video for you. If you have any questions or suggestions, please write it down in the comment section. I'll try to get back to it. Have a good day. Thank you.